Hey guys, I'm going to be helping you out with lesson 14's homework. Before we get started on this page, let's cross out some ones that you should have crossed out today in class. In case you didn't in class today, go ahead and cross out all of number 2. If you want to do it, if you have extra time, you can, but I won't be going over it in this video. Okay, let's look at number 1. It says compare the pair of fractions by reasoning about the size of the units. Use greater than, less than, or equal to. Okay, so think about 1/3 and 1/6. If you can imagine what that looks like, oh, let me fix my circle. That doesn't look too proportional. Okay, so think about 1/3 of a pizza and then 1/6 of a pizza. Now, some of you might be thinking 1/6 would be larger because 6 is bigger than 3. However, the more pieces you split it into, the smaller they're going to be. So really, even though the third is a smaller denominator, that makes it bigger because the bigger the pieces are. So 1/3 is greater than 1/6. Now look at B, 2 halves and 2/3. Well, 2 halves make a whole. 2/3 are less than a whole, so obviously 2 halves is going to be greater than 2/3. Okay, let's look at C, 2/4 and 2/6. Same thing. The bigger the denominator, the smaller the pieces it's going to be separated into. It's kind of the opposite of what you would think. So 2/4 is going to be greater than 2/6, and I'll demonstrate that on here. Okay. Last one, 5/8 and 5/10. Same principle applies. I'll try to make the pieces look as even as possible when I draw it, but 5/8 is going to be larger because eighths, the pieces are bigger than if you have to split it into tenths if the whole is the same size. So 5/8 is going to be larger than 5/10. So here are my 5/8, 3, 4, 5. And then if I draw my 5/10, that's going to be about half anyway, and 5/8 is a little bit more than half. It's kind of hard to see with this pencil, but 5/8 is going to be larger than 5/10. 1, 2, 3, 4, and 5. Okay, moving on to the next page. Okay, let's see, before we start page 2, let's see what we need to cross out. Looks like we need to cross out part C, so if you could go ahead and do that on your papers. And let's look at the directions. It says draw 2 tape diagrams to model each pair of the following fractions with related denominators. So really we're still comparing, but each time it's asking us to do it a different way. So I'm going to draw 2 tape diagrams. First I'm going to represent 3/4. So 1, 2, 3. And next I'm going to represent 7/12. Now because I'm going to be comparing it to 12ths, I'll show you what I'll do in a minute, but first let's draw a rectangle, separating it into fourths, and then I'm going to separate each fourth into 3 so I get 12 pieces. Okay, I need to color in 7 of those 12ths. Making sure it's 12. All right, 1, 2, 3, 4, 5, 6, 7. Now it already looks a little bit smaller, but my drawing might be off a little bit, so let's check. If I separated that 3/4 into 12ths, kind of like we did with equivalent fractions, let's see how many 12ths it would be. 1, 2, 3, 4, 5, 6, 7, 8, 9. So really 3/4 is the same thing as 9/12. I can prove that with multiplication. And we're comparing it to 7/12, so obviously 9/12 is going to be bigger than 7/12, which makes 3/4 bigger than 7/12 as well. So 3/4 is greater than 7/12. All right, let's look at part B. It says 2/4 compared to 1/8. Even though I already know the answer to that one, we're still going to draw the tape diagram because that's what it asks. So we're going to color in 2/4. And then we're going to compare it to 1/8. Well, we should automatically know that's smaller, but let's try it again. So if I separate this into fourths, I can split each fourth in half to get eighths. And then if I color in one of those eighths, it's super clear from this picture that 2/4 is bigger than 1/8. In fact, 2/4 is equal to 4/8 anyway. And I'll prove it here. 4 times 2 gives you 8, and 2 times 2 would give you 4. So 2/4 is equal to 4/8, which is obviously going to be bigger than 1/8, so that you know that 2/4 is greater than 1/8. All right, let's look at the next page. And let's cross out the ones that we are not going to complete today. So let's look through these. And it looks like we're going to be crossing out C and D from, excuse me, number 4. And then I'm also going to cross out A, B, C, and D from number 5. That leaves us with just a few to do. Alright, so let's look at number 4. It says, draw one number line to model each pair of fractions with related denominators. So now instead of a tape diagram, it wants us to show that we know what we're talking about with a number line. So I'm going to start off with a number line. Going to label my 0, going to label my 1. And we're comparing 3/4 to 5/8. So the first thing I want to do is split my number line into fourths. And so 3/4 would be here. And now I'm comparing it to 5/8. Well, an eighth is half of a fourth. We know that when we were talking about equivalent fractions. So I'm going to split each one of these fourths in half. And then I'm going to count to figure out where 5/8 is. Well, let me label them all. Here's 1/4 and 2/4. And then let's count by our eighths. So the green, that would be 1/8. 1/4 is the same as 2/8. Then we have 3/8. 2/4 is 4/8. And then 5/8. 3/4 would be the same as 6/8, and so on and so on. But here we can see that 5/8 is less than 3/4, so we're going to say 3/4 is greater than 5/8. Okay, we're going to repeat the same process again for B. So I'm going to draw my number line, 0 and 1. I'm going to start off by splitting it into fourths. I'm going to label where each fourth is. And now I have to split it into 12ths, and if I do that, if I split each fourth into 3 parts, that'll give me 12 total. So we're going to do that. And if I count it by 12ths, that'd be 1/12, 2/12, 1/4 would be under 3/12, 4/12, 5/12, 6/12 is the same thing as 2/4, 7/12, 8/12, 9/12 would be 3/4, and then 10/12 and 11/12. So 11/12 is bigger than 3/4 because it's closer to 1. So we would say 11/12 is greater than 3/4. Okay, down here on number 5, we're doing the same thing, but it says draw a model if you choose to. You don't have to if you already know the answer, if you can reason it out in your head. So let's look at part E. It says 3/4 compared to 9/12. So I'm just going to draw a number line just because, just to show you guys. 0 and 1. And I'm going to split it into fourths, like I have been. And now I'm going to split it into 12ths as well, like we did in part B of number 4. Now, if I counted to where 9/12 would be, so 1/12, 2, well, these are going to be kind of squished. Hold on. I think I'm going to have to fix this. Okay, you can't really read that. Let me go back. Okay, 2/12, 3/12 the same as 1/4, 4/12, 5/12, 6/12 is the same as 2/4, 7/12, 8/12, 9/12 would be where 3/4 is, and then 10, 11, and 12/12. So 9/12 is actually on the same tick mark as 3/4, so that would make them equivalent. Well, let's check that with some multiplication. Let's put 3/4 is equal to 9/12 and make sure it works out. Well, 4 times 3 would give you 12, and 3 times 3 gives you 9, so they are equivalent. Okay, and now let's do the last one. F is 5/3 compared to 5/2, and obviously 5/2 is going to be bigger than 5/3 because halves are bigger than thirds. If I have 5 of them, of each, 5/2 is going to be bigger. Okay, checking out this last page, and these are all fractions with denominators that we do not study yet, so you shouldn't have been given this last page of homework, but if you are, you could cross it out, or you could use it, or you could try it on your own for practice. Thanks, guys.